Good afternoon. This is Ms. Billerbeck, and we're going to talk about factorization by extracting common factors. So extracting is like taking gold out of quartz. In California, we have tons of quartz. So let's pretend that this is gold and these are types of quartz, and we want to extract the gold out of them. So when we extract the gold, that's A, it leaves behind this type of quartz and that type of quartz. So if we have AX plus AY, that equals A times X plus Y. Okay, so the process of writing an algebraic expression as a product of its factors is called factorization or factoring. So one thing we want to do when we're factoring is to break things down into prime factorization. So if we use a factor tree of 21, so it's not divisible by 2, but it is divisible by 3 because 2 plus 1 is 3. 3 is divisible by 3, so we can take a 3 out and we have a 7. So we have 3 times 7 times A plus, and then we have 18. 18 is even, so it's divisible by 2. And 18 divided by 2 is 9. 9 is definitely divisible by 3. And that leaves us 3. So now all of our numbers are prime factorized. So we can write 2 times 3 times 3 times B. So we want to find what is in common with these two prime factorized numbers. And we see, oh, there's a 3 and a 3, but there's no 7 and there's no A in this number. So that's all that's going to come out. So the prime factorized version of this is 3 times 7 times A is 7A. Plus 2 times 3 is 6. 6 times B is 6B. So that would be the prime factorized version of this. So let's look at the prime factorized version of this. Okay, so this is a Y there. So if we broke 14 up into its prime numbers, so we have 14, let me use a different color here. So 14 is even, so we can take a 2 out and we have 7. Okay, then 35, it's not divisible by 2. It's not divisible by 3 because 3 plus 5 is 8. 8 is not divisible by 3. So our next prime is 5. It ends in a 5, so we can take a 5 out. So we're taking a 5 out and we have 7. And these are both prime numbers. And then 7 itself is prime. So let's look at how this breaks up. So we have 2 times 7 times B times Y minus 5 times 7 times B times Z plus, and then this is 7 times B. So now we look at what do they have in common. So we see, oh, they each have a 7. So we're going to take that 7 out. But wait, we're not done. They have more things in common. They have a B in common as well. So we can take the B out too. So when we put this together, we have 7B times, and 2Y is left over, minus 5 times Z, which is 5Z, and then 7 times B. Well, we took that out. What's left? What is this number? Whew. Well, let's look at the process that we actually did, okay? And then it'll teach us what that number is. So let's go back to taking this step here. Okay, so if we want to take the 7b out, we can't just take a 7b out. We have to also do something else to all these things. So we have 2 times 7 times b times y minus 5 times 7 times b times z plus 7 times b. But we can't just put a 7b out here without also dividing by 7b. Because really, what is this? What's 7b over 7b? Well, that just equals 1. Okay, so we haven't really added anything if we do write 7b times this original expression right here. Okay, so now let's rearrange this. And now I'm going to divide all of this by 7b. So that means that this 7b goes away, that 7b goes away, and that goes away, but when it goes away as 1. Aha! So we're getting there. So what is this then? So we have 7b on the outside, and we have 2y minus 5z left over here. And then, oh, look, it's just 1. That's all we have left over is 1. So that was the magic question. This question mark was a 1. Okay. All right, that's it for this section 4.4 of factorization. Have a wonderful day.